Hello everyone, welcome back to our YouTube channel. In today's discussion, we discuss a very interesting question from the partial differential equation, and this question is asked in the CSIR net December 2025. Okay, in this question, uxt is the solution of this second order linear partial differential equation, and this linear partial differential equation is associated with boundary and the initial condition. Okay, the boundary condition is given this one, u0 t is equal to 0 and u pi t is equal to 0, means here the Dirichlet boundary condition is given, and at the initial condition it is given that u x0 is equal to sin x and ut x0 is equal to 0. Ut means here ut denotes the del u by del t. Okay, and similarly ux denotes the del u by del x. Okay, partial derivative with respect to time and partial derivative with respect to x. Okay, these are the symbols. Okay, and what is given here, the energy function Et is defined in this way. Then we have to verify these four options. Okay, we have to find the bounds on this energy functions, whether this bound is greater than equal to pi, less than equal to pi, greater than equal to pi by 2 and less than equal to pi by 2. We have to verify these four things. Okay, so here energy function is given, so our natural method is to apply the standard energy method. Okay, so we rewrite this equations and name it, this first one is equation is 1 and the boundary condition is equation 2 and the initial condition is equation 3, and our energy function is this one given. Then we will differentiate our energy functions on the both sides, then we will reach to this step. Since our function u is twice differentiable, so here the integrand in this expression is differentiable, so that therefore by using the Lebesgue rule of differentiation we can take that derivative inside. Okay, so it gives this expression, because derivative of ut square with respect to time gives, by using the product rule we will get this one, and similarly if you apply the product rule here you will get this one. Okay, so we reach to this step, because when the derivative comes inside it will be like partial derivative. Then you will apply the, first you will apply the power formula, then you will apply the means I am saying that you can calculate this thing del u by del t ut square. If you apply power formula or and the chain rule, then you get 2 ut. By using the chain rule it gives ut. Okay, so you will get this first term, then using the similar argument you will get this second term. Okay, now I am taking the second term and keeping the first term as it is, so we will consider the second term, this one. Here this uxt is given. Okay, uxt means the partial derivative del u by del t of del u by del x, and we know that this, since this u is a smooth function, because it is twice continuously differentiable, so this thing is equal with del u by del x del u del t. These two things can be interchanged, so in the next step we have written this thing. Okay, because this is equal with this, because u is our smooth function. Okay, now here you will look here the derivative with respect to x and integration is there, then we can apply the integration by part formula, means we will shift the derivative to here. Okay, if you apply the integration by parts formula, there is a boundary terms comes, and this is the second term. Okay, in the boundary term if you open it you will get this term and this term. Okay, but if you observe that here boundary term with ut pi t is coming and ut 0 t is coming, these values are 0. Why? Because u pi t is equal to, because u0 t is equal to 0 and u pi t is equal to 0. These are the boundary condition. Means u0 t is a constant function, u pi t is also a constant function, they are not changing with respect to time. So if you take their time derivative, so it gives 0 and it gives 0, therefore this term will vanish and this boundary terms will vanish. Therefore the boundary term will not appear for this expression. Therefore by using 6 in 5, we will get that this thing here, boundary term will disappear because they are vanishing. Now using 7 in 4 means if you will put this values, this you will, if you will use this 7 in 4, you will get that, you will get this expression. Okay, here ut and ut are common thing, so you can take out 2 ut, so you will get this expression, and this expression is equal to what? Minus of ut. It is coming from the equation 1. If you look at the equation 1 here, ut minus uxx is equal to, if you take this term on the right hand side, it gives minus of ut. Okay, so utt minus uxx equal to minus of ut. So it gives this expression is minus of ut, so it gives 2 times minus of ut square, so minus 2 comes out, so you will get this thing. And this is since ut square is a non-negative thing, and minus here minus is coming, so therefore this quantity is non-negative, therefore this quantity is negative. Okay, so this quantity is, therefore this derivative is less than equal to 0. Then you will take the integration from 0 to t on both sides, then you will reach to this step, and this step implies that it is less than equal to e of 0 for all t greater than 0. Okay, and but now we will calculate the bound e of 0, value of e of 0. The e of 0 is equal to what? Because it is defined in this way, it is the definition of it is this one. At time t it gives 0. Okay, at time t, I am saying that at time t, if you put t is equal to 0, here also t will come 0, and t here will put t equal to 0, then it gives this expression. But utx0 is what? Utx0 is this one 0. Okay, means here utx0 is this one 0, and ux0 is equal to sin x, and its derivative will gives cos x. Okay, so utx0 is 0, this is 0, and ux0 is sin x, and its derivative will gives cos x, so it gives cos x square dx. And if you will apply the some integration technique on cos square x by using the class 12 integration, then you will reach to this pi by 2. Okay, since the cos x integration will give sin x, and sin the function vanishes at 0 and pi, so it will not give any contribution, therefore it will give pi by 2. Okay, so e0 value is equal to pi by 2. This implies if you use equation 9 in equation 8, you will get it is less than equal to pi by 2 for all t greater than 0, this thing. Okay, so finally we concluded that it is bounded by pi by 2. Let us verify the options. Means we infer that it is less than equal to pi by 2 for all t greater than 0. Okay, so which one is true? It is saying that it is always greater than pi. This is false because it is less than pi by 2, and it is less than pi, because it is less than pi by 2 implies what? It is also less than pi, so it is true. Okay, and it is saying that it is greater than equal to pi by 2, it is false, and it is less than equal to pi by 2, it is true. Therefore option 4 and option 2 are correct one. I hope that you all understood it very well, and this method has a very nice name. It is called the energy method. Okay, keep remember it. Thank you all. Bye bye.